Okay, hello everybody. So today we are doing a little review. So you should get a worksheet out, handed to you, and then all these problems, I just want you to follow along. You can pause when needed, just to make sure you're following along correctly so you're preparing for the next test. Calculator's out, and now you just have to remember the rules. So here's what it should say on your worksheet. If not, pause the video, get that worksheet out, write these examples down if you don't have it, okay? And let's go. So when we're multiplying, remember we can multiply anything that's both under the radical with under the radical, or outside the radical with outside the radical. These are both under the radical for this one, so I'm just going to really multiply them together is really what's happening. And 15 times 25, everybody check in your calculator, is 375. And because it's a square root, remember, two of a kind. We're back to that. Now we just make our tree, and I know it ends in 5, so it's 5 times 75. Does that make sense? And then 75, again, ends in 5, so it's 5 times 15. And I know 15 is 3 times 5. So I have a pair of 5s, and I have left over, and remember, this is our leftover spot. So my final answer is 5 radical 15. That's simplified. Okay. Now, for the next one, please note this is outside the radical, and there's nothing else outside the radical, so just keep that out. And now both of them are under the radical, so I'm going to start by going 15 times 20, and that gives me 300, and that's just multiplying 15 and 20. Okay, now we do the same thing we've been doing. I know 300 is 3 times 100. Remember, we're looking for matches. Now, if you remember, 100 is 10 times 10, which gives me a match. You can keep going if you choose, but you could have stopped there. Remember, we're only looking at the ends of the tree. So I have a pair of 2s, a pair of 5s that I'm taking out, a leftover 3, and not forgetting to bring that down. And then I just go in my calculator, -2 times 2 times 5, which is also 10, -20, radical 3 is my answer. Okay? Okay, here we go. Let's keep going. Okay, now again, the 3 is outside the radical, and 10 times 5 is 50. Does it make sense? Now, I just continue to break it down. You can do it in different ways. You could do 5 times 10. You can do 2 times 25. But 10 is 2 times 5. Again, I'm looking for that pair and the leftovers. And don't forget to check out front. And remember, this is a big multiplication problem, really. And that's what I get. Okay? Okay, so far so good. Now the only difference, this one has a -5 and a +3 out front. So what is -5 times +3? That's -15. Then 6 times 15, do it in your calculator, you should get 90. It's a big multiplication problem, okay? 90. The easiest way, I think, is 9 times 10. It ends in a 0. And we keep going and looking for matches. Okay, the only match I see is a 3. The 2 and the 5 are left over, and I check up top. Yep, that -15 is out front. Okay? Now, in your calculator, -15 times 3 is -45. And 2 times 5 is 10. Done. Okay, so hopefully you're getting really good at those. Distribution. Now remember, that is like saying 4 times radical 6 minus 2 times radical 3, when I do the second one, times radical 6. That's what that means. So this is 4 radical 6 minus 2 times, now the 3 and the 6 are both under the radical, so that becomes 18. Okay, now simplify. The 6, the only way I get it is 3 and 2. It's not a repeat, so really kind of ignore it because I can't do anything. 2 times 3 is still 6. But 18 is 2 times 9 and 3 times 3. Okay, so I'm going to start by bringing that down, looking for my repeats and take them up, my pairs, looking for my leftovers. Okay, so that now is 4 radical 6. Now I'm just multiplying things out, and 6 radical 2. And I can only add them or subtract them if they're both the same radicals. This is like saying 4x minus 6y. Because they're not the same number under the radical, I don't combine them anymore. Okay, next, start by here. Now I like to write the big numbers first, meaning if I have a number out front of a radical, times rad 2. And again, I'll do that again. Times 2. Remember, when we're distributing, we're timesing. Okay, so now this part here becomes 2 times radical 20. This part here, where the 2 and the 2, this 2 and this 2 are both outside of a radical, so that's where I'm getting 4. And that rad 2, or square root of 2, gets left over. Break down 20. 4 and 5, 2 and 2. So I bring that down. I look for my pairs or 2 of a kinds. My leftover goes in the leftover spot. Then the plus. Now, can I do anything to radical 2? No. Now I just multiply this 2 times 2, which is 4. And that remains the same, and I can't combine them because they are not the same radicals, okay? Okay, here we go. Division. First things first. Please note, square root of 9 is 3. So I'm going to get rid of a perfect square right away when I can. Okay, but 20 can also be simplified. I'm just looking at the top. 4 and 5, we just did this one, it feels like. 2 and 2. So the square root of 20 is 2 radical 5. Do you see that? So that also goes on the top instead of this 20. So it's really 2 radical 5. I'm getting that from the bottom. 3 times 5 is 15. Now, can I reduce the 2 and the 15 since they are both outside of the radical? They are not reducible. So this is what I got. Okay, I'm going to bring this one down a bit just so I can reach it a little better. Now, this is like having a little 1. I can't reduce the 3 and 1. I look at the radicals. Are they either one a perfect square? Neither one's a perfect square, but can I simplify 3 and 75 since they're both under the radical? Well, does 3 go into 75? I'm trying my calculator. Yep. So I'm dividing both of those radicals by 3. So this becomes 3 rad 1, and then I have a little 1 out front. 75 divided by 3 is 25. Okay, the 3 goes along. The square root of 1 is 1. The bottom is 1 times the square root of 25 is 5, so that is really 3 over 5. Do you see how we did that, hopefully? Okay, we're almost there. You can see it on the sheet. Okay, so here we go. So the top one, first thing, do you see that 2 over 2 reduces to 1 over 1? Just to make our lives easier. Okay, now 15 and 80 are both under the radical. Are either one a perfect square? No, but I know they both are, I can divide a 5 out of both of them. So on the top I have a 1. 15 divided by 5 is 3. On the bottom I still have that 1. And then I go 80 divided by 5 is 16. Okay, I'm going to bring this one down just to make it easier on you guys. So 1 times rad 3 is just rad 3. 1 times rad 16 is really 1 times 4. It's a perfect square. So this is really just rad 3 over 4. You could put a 1 out front if you want. Okay. Meaning, if you want to keep that 1 here, you can. So again, I still have a 1 there if you want to put it there, but 1 over 4, again, not reducible. 3 is not a perfect square. 12 is not a perfect square. But I do know I can divide a 3 out of the top and the bottom. So that becomes 1 rad 1 over 4 rad 4. Look at that, take it in. Okay, radical 1 is 1, or the square root of 1. The 4 times the square root of 4, the square root of 4 is really 2. So this is just 1 over 8. Okay, I hope that makes sense. Okay, if we need to go back to any. So you have a review worksheet today of everything. Then please double check that your answers are correct. And you do have a Schoology formative today to go into Schoology, okay? Use each other as resources. Go back if you need to, and have a great day, okay? See y'all later.